In this lesson, we will take a look at the curriculum of the course. The course can be divided into four broader levels. That is, the first is generic programming, where we will learn about the mindsets of a programmer, how our computers work, and how it handles data. Then we'll take a look at what programming languages are and how they work. We will also learn about the terminal and perform some basic operations with commands. After completing this section, you will learn the basics of programming in general and be ready to start hands-on programming. That's why in the second level, we will start programming with Python. We will install Python and Visual Studio Code, that is a code editor, in our system to start programming. We'll perform some basic calculations and learn about the basics of Python syntax and expressions. Then we will learn about the data types and if statements while creating a phone book application. It will be a fun exercise for your very first application. As a bonus, we'll also create our own function to set our terminal on fire. That concludes the curriculum of the course, and there's a lot to cover, so what are we waiting for? Let's get started. Before we start the course, let's discuss some key principles to keep in mind before jumping into any sort of programming. You can see that I've divided the information into easy to digest short video lessons. I think this will go easy on your brain instead of long lectures. Also, while we're talking about the lessons, you will see extensive use of graphics and images throughout the videos. In this age, when you're surrounded by multiple devices, especially your smartphone, you're receiving too many stimuli by consuming loads of contents every day. You're likely to forget things learned here if they are presented in a usual plain way. I hope it helps you learn the concepts better and also retain the information. There are also other elements like infographics, code snippets, etc. which I'll explain when we come across them. I will go over some principles that you should keep in mind while you're taking this course with some mindsets which will help you learn efficiently and face few issues while programming. As when it comes to programming, it differs from most of the other jobs because you'll be doing 0% of the physical work and 100% of the mental work, mostly. So you should be developing as a programmer mentally as well. So the mindset number one is being lazy. Yeah, it's true. Note that I don't mean being a sloth here. What I'm getting at here is that it's not you who should be lazy, but your mind which needs to be lazy. Didn't get what I mean? Let's discuss it further. So who is considered lazy? Anybody who just lays around like a sloth or does their work slowly with no energy at all, right? If that's what you're thinking, then you're probably right. I hope you don't have any of those characteristics. Of course, being lazy is not a good thing, but take it this way. You're given a task to rename hundreds of pictures in a folder according to their name with their current name, like let's say blue sky number 1 PNG. So how will you do it? Let's say Harry thought like, it's a big deal, but I will rename those pictures manually one by one as this is my job. Pressing right click, hitting rename and entering the numbers while keeping track of each picture's number. At minimum, Harry will take 8 minutes. But Sam thought like, wow, looks troublesome. I can't do renaming for hundreds of pictures again and again. Maybe let's see if there's an easier way to do it. Okay, by running a script, I can rename any number of files in seconds, but I don't know how to program. Let's ask John to help me. And with the help of John the programmer, Sam learned how to execute a script and got the work done in mere 2 minutes, taking the learning time into account as well. In the above two cases, you can instantly point out what's better, right? But there's more to it. I'm sure you probably reacted like Sam, but depending upon the person, they might or not perform the next step. That is, getting the work done with as minimal effort as possible. Here what I want you to take out is, even if a task may sound tiresome, who said you have to labor that much? Just try to find out the possible solutions and see which one allows you to reach the goal with minimal effort. For several hundreds of folders, Harry had to toil for hours and also introduce errors while counting and get frustrated if he had to repeat over again. But given any size, Sam would not have any problem. Even though Sam took time to learn a new skill, running a script will take no more than a blink of an eye. Note that Sam asked for help from John as he didn't know programming, which we will discuss further in a minute. Now, this type of laziness or first thinking and then reacting can also be called placidness, which is our mindset number 2. Now, what if Sam encounters some issues while running the script, like pictures not being renamed properly or nothing happening at all? What will you do in Sam's shoes here? Will you become Harry or bombard John? I'll keep Sam's image so he does not freak out. Instead, he keeps his calm and concludes that something has gone wrong because he is missing something here. As he is running the script using an application called Terminal, there are some things showing up which is definitely related to the problem. He asks John and finds that he missed a certain step, that is, the script didn't get the permission to rewrite the file names. So he does just that and his problem gets solved. Now, what if he shrugged it off, telling he doesn't get it, or even worse, blaming John that he screwed up? Your life may not go as you'd expect it to, but programs will have errors for sure. It's a fact you have to take for granted. The faster, the better. As a newbie, I've struggled a lot whenever something has gone wrong. Instead of finding out the cause of the issue, I blame the computer that something is wrong with it. Whenever you're writing code, you should expect it to have errors. It's better to be ready for the worst instead of getting shocked later on. If any error occurs, handle it gracefully instead of beating your head up against the wall. You can use laziness in this case to your advantage as well. Whenever you're stuck on a problem for quite a time and no solution comes in sight, go ahead and take a break. Mindset number 3, being social. Whether you are an introvert or extrovert, you should know the fact strength in unity. Now, I'm not talking about posting yourself coding on any social platform, but the best thing when starting out your programming journey is to join a community. You're not in this alone. There are a lot of people learning. Some started earlier than you, and some will start later from now. If you become an active programmer and work on projects, you will encounter problems. Of course, you can Google them, but posting your question in a community has greater chances of you getting guidance as well. When I started out, I messed a lot with things ahead of my curriculum and got into a lot of errors. Whenever I posted a question in communities, I always got a great response, which helped me understand the value of community. We also have a community that has a lesson dedicated to itself. While we are talking about community, most beginners have a stereotype that expert programmers sit in front of a large screen while typing like a mad with long chains of code. That's not true at all. An expert programmer thinks more than typing. It's not about the length of the code, instead getting the job done in the minimal and efficient way possible. It's true that you could be dealing with hundreds of lines of code, but write less code which has great value. Moving on to mindset number 4, that is divide and rule. I'll be borrowing the quote from Napoleon Bonaparte, that is divide et impera, or in English, divide and rule. Though we are not talking about anything political or being ambitious, right? If you read between the lines, the quote means steering conflicts between your subordinates to gain or manage power. That's not what I mean here. What I'm getting at here is that your enemy is the new concepts that look scary, like metaclasses or decorator functions. Of course, you don't know these terms, but whenever you find a topic that you cannot understand or just can't get through your head, just use this rule. Break it into pieces that you are comfortable with. I've already mentioned this, but here's the technique. Learn seemingly difficult things in smaller parts. If that does not help, learn it in intervals. It's better to read a single paragraph 3 to 4 times and understand it better instead of reading a whole section at once, being left with partial understanding. Every teacher explains things in a different manner. Now, it's your task to divide it and make it suitable for your consumption, comparing it with something you like games, etc. And then defeat it. To give you a live example, try eating any food in large portions in one go, and then trying eating it small portions. Go ahead and try it today. I will encourage you to either write down these mindsets on a piece of paper and keep or stick them in front of your computer. This way you will keep these in mind when they needs to be performed. I've seen myself that remembering them is pretty easy, but implementing them in action is really tough. Personally, for me, I had a lot of trouble when I started programming. Most of the concepts went over my head and I struggled a lot with issues that seem too low now. That's why I'll try to pour in pieces of advice along with every code or concept to prevent the same happening with you. It may seem a bit overkill for you now, but at the end of the course, you surely realize it. I remark it once again. Whenever you're having trouble understanding, just get a break and look at it again, as your mind will get the task done, so don't push it like your body. Even though programming does not require you any knowledge of the hardware you're working on, but it does not hurt to know the basics of a computer's architecture. We'll also look at how data is stored in our CPU or hard disks. And by data, I mean your ordinary things like images, text, and other files. Even though the computer starts with the press of a button, there goes a lot behind the scenes which we'll take a look at. The first thing is the computer components which constitute the computer itself. Even though there are a lot of parts in a computer, we will be focusing on the main three components like the CPU, RAM, and GPU. And the main component in these three is the CPU, aka Central Processing Unit. I hope that you're aware of that already, but do you know what lies inside of a CPU? A computer mostly requires one CPU, which is also known as a microchip or an integrated chip, which does all the heavy lifting behind the scenes. Microchip relies on electrical components called transistors to function. Transistors are technical switches that are either off or on at any given time. Off means 0 and on means 1. Now, why is that? Well, we will take a look at that in just a second. A single microchip can contain millions or billions of tiny transistors embedded on it. Each CPU has something called an instruction set, which is a collection of binary zeros and ones commands that the CPU understands. Luckily, we don't really need to worry about these things as a programmer. It will be translated for us by an interpreter or an compiler. It's great that our CPU is handling the heavyweight lifting, but it needs a power rack to place the weights on. What I mean is that the CPU needs to store some data temporarily, which is offered by our RAM or random access memory. When starting any program or software, there appears a loading screen. That's the time when all the program files are loaded onto the RAM from our hard disks. In your computer, you may store all kinds of data like images, documents, videos, or other files, but does the CPU looks it like VC as well? The answer to that question is no. As mentioned previously, the CPU knows only two things, 0 and 1, that is the transistor being on or off. And when it comes to things like images, it sees as a long sequences of zeros and ones. These zeros and ones are also called bits. Bits are stored in a set of 8 that is called byte. Let's watch this in action. I'll create a file.txt, open this in Notepad, and then insert code, that is code word inside of it. I'll save the file, and then back to the File Explorer. When I hover over the file, you will see the file size change to 4 bytes. Now, as you can see, the file.txt contains the code word whose length is 4 words, and the size of the file is 4 bytes. I think you've got what I wanted to demonstrate here. For us, file.txt consists of word code, but for our CPU, it is 4 bytes, that is 32 bits long, which is something like this. Note that this is not the exact representation, but something along those lines. This type of representation is also called binary representation. Go ahead and try this yourself. Also, see, can you predict what will be the size of a file containing the number 1092 or even an emoji? But what about the other files whose size in KB, kilobytes, or megabytes, or even gigabytes? Well, 1 kilobyte represents 1024 bytes, 1 megabyte represents 1024 kilobytes, and vice versa. Now, just think about the binary representation of an image of size 2.4 megabyte or worse, a movie of 1.35 gigabyte. I guess the position of CPU just got elevated in your mind. That's what computer and data was. But before we end this lesson, I'd like to remind you that computers have memory but no imagination. We don't have memory, but we have imagination. See you in the next lesson. In the previous lesson, we learned that the CPU is the one responsible to perform most of the tasks, and also how it handles data in bits and bytes, that is, long sequences of zeros and ones. Now, how do we tell the CPU to perform something? Let's say we want to know what is the product of 8 and 21, that is a simple mathematical task. The straightforward way would be to represent the problem like 8 multiplied by 21 in bits and bytes like this. This binary representation is just a representation of the problem as plain text. The multiplication operation has an operator which tells the CPU to multiply the number before to after it. But what if the problem would be more complex or long like this, or even like this? Now, it will be painful to type out long chains of zeros and ones like that. This representation of instruction as long sequences of zeros and ones is called machine code. But that's how Harry would do, but Sam is lazy, so he will find a better way to get the job done. So what can be done here? As mentioned in the previous lesson, each CPU has something called an instruction set, which is a collection of binary zeros and ones commands that the CPU understands. Now, how about we create a thing which will handle the translation of literal text like 8 multiplied by 21 into machine code, and we don't have to deal with any zeros or ones. Also, like any other tool, it should scale well, like I can implement a simple mathematical calculation to several lines long calculations. Using that thing, we can narrow down the required scope of our understanding and skills and work with higher level tools that is called abstraction. So, can you name that thing? I'm sure you do. It's programming languages. A higher level programming language like Python or JavaScript provides a set of human readable keywords, statements, and syntax rules that are much simpler for people to learn, debug, and work with. Programming languages provide a means of bridging the gap between the way our human brains understand the world and the way computer brains, that is, CPUs, understand the world. Ultimately, the code that we write needs to be translated into the binary instructions or machine code that the CPU can understand. Depending on the language you choose, we say that our code is either compiled or interpreted into machine code that is capable of being executed by our CPU. Most programming languages include a program called a compiler or interpreter which performs this translation. Basically, a compiler will look out for all the errors in your script and then report it back to you. An interpreter stops when it finds the first error. If no error is found in the compilation, you get an executable which will generate the output, while with interpretation, you get the output instantly. Here is a Python code snippet. What I want you to do is try to read and understand what this piece of code is trying to do. I know you may be like this, but as a beginner, you should develop the habit of reading and observing code. A lot of beginners call long code scary, which I thought as well. That is, how can a person understand this? But there is nothing scary here. It's the thought which is holding you back. If you can read books with long chapters, then reading a few words as code is nothing. Start by getting comfortable looking at the piece of code. Then go ahead and give it a read. Something gone overhead? Give it a read again. I'm not telling you to take this as a lesson. It will be a fun activity looking at the code and guessing what it probably will do. Write down your thoughts in a piece of paper when you think you've got what the code means. Good luck! So what's the difference between a programmer and a non-programmer computer user? Well, it will be the terminal. As we learned in the previous lesson that we can use programming languages to contact our CPU, but we can do a lot of things in our computer without doing any programming at all, like creating a file, reading any text file, or other tasks. Most of them are done with the user interface provided by our operating system or other software. They're using a programming language to display you easily recognizable button with an appropriate label on it. You can click the button and that triggers a piece of code which then tells the CPU to perform a certain task. Now, I hope you know what an OS or operating system is. For just a refresher, it's the base program which unlocks a lot of functionalities to you. The most popular OS on a computer level are Windows, OS X, and Linux systems. These operating systems come with a built-in file manager along with some other essentials like Notepad or some sort of plain text editor, image viewer, etc. You can install more apps or softwares according to your need. But there's also a piece of software called terminal. If you have some programming background, you will know what it is, as you may have seen the same in movies where terminal is just a black window with overflowing green text which just keeps scrolling. The terminal is a software which allows you to perform all the basic function on the OS level like viewing files in a folder, reading a file, creating or editing files, and so on. The only difference is that you'd be performing those actions using only your keyboard, that is with commands. It will be weird at first, but trust me, when you will keep using it more often, you will understand its potential. Now, if you are a Windows user like me, then this terminal thing here is called command prompt. If you're on a Windows machine like me, go ahead and install Windows Terminal. So open up the Microsoft Store and then search for Terminal. Select the one with Windows Terminal and install it. So what it will allow you to do is get rid of the command prompt and execute the terminal commands right on Windows. And of course, you can do the same on Ubuntu and Mac because they already have terminal. But for Windows, some people try to use command prompt, but I recommend using terminal on all over the systems. Okay, this way things will be consistent. So from now on, I'll be referring to all of them as just terminal. Now that we have installed the terminal application, how do we open it? Now, mostly you would have a desktop shortcut over somewhere here, which you will double click and the application will run. But when it's not there, what you can do is just go to all apps and then search for the same, and you can double click this and it will also open up the application. But I don't want that because as a programmer, we tend not to use the mouse because that's slow. So when we are coding, we have our hands on the keyboard and we want to do all of the actions with keyboard, which is of course possible. So here what we can do is press Windows S, which will bring up the search bar. And you may or may not know the same, but you can just hit Windows S, which will bring up this search bar. Type in your application name, that is the Windows terminal here. Hit enter, the terminal will open up. Now it's just a tip as a programmer because, as I mentioned, we tend to use the keyboard more than the mouse. Okay, back to our terminal. As you can see, it's kind of bland. Its user interface does not have any buttons. Though you can see it has a tab right over here, which is the Windows PowerShell. And then we have this line and then a cursor like this. Now, to make things a bit bigger because they are really small now, I will hit the Control and equals sign, which will increase the font size of the terminal. Okay, this is better. Now you can see that we have some Windows PowerShell information, and then we have a line like this. In terminal, we call this a prompt. In this prompt, you can see we have the line starting with PS, which stands for PowerShell. Then we have the current working directory. I'll get over that in a bit. Then we have a arrow, and then we have a cursor where we can type in any command. So the main thing here is that we have a prompt which shows our current working directory on which we can execute some command. Now take it this way. Let's say I open up this same location with my file manager. So I will go ahead, open a file manager, then go to this PC, C directory, and then where's user? Okay, here, and then my home directory. So I opened up this here, and then you can see what I can do here is that I can see how many files are here, and then I can create new files, but just with the right click, like new file, or even I can copy paste some things, etc., etc. These things are called some functions, and the same functions can be executed with this plain terminal. So the first thing is, as you can see, I opened up this whole file manager directory right with the mouse click thing. So as I mentioned, we should not do that as a programmer. So instead what we can do is again use the Windows search option, then type out the file location, which will open up the same for us. As you can see, it's already opened up. That's why it didn't open up. So yeah, that's again another tip which you can use instead of your mouse and click thing. So I'll just keep it in the side. And now you can see that how can we know where we are? So of course, you can see that the prompt shows our current working directory, but we can also know that using a certain command, which is called pwd. So type in pwd, this is a command. And then if I hit enter, we get an output. So this is the output, which shows our current path. This is C users/Rahul. So if I open up the file manager, you can see the same that is listed over here. So in file manager, we have this current working directory. In our terminal, we have that as our output, and also on our prompt. In file manager, we can go inside of any directory or folder just using the mouse clicks. Like let's say instead of the C drive, I want to go inside of the X drive. So in terminal, we can do the same using the cd or change directory command. So right now we are inside of this directory. We can change that using the cd command and then provide it a path we want to go. Now, as you can see, this is a path that is C users Rahul. Okay, so by path, I mean just a folder destination. So here we need to pass a path. So I want to go inside of the X drive. You can see the drive starts with a colon like this. So I'll hit enter. So what we did here is changed our current directory from our C users Rahul to X drive like this using the cd command and giving it the destination or the folder where we want to move inside. Now here you can see that the prompt changes to just denote our current working directory, that is this X drive. Now this command is just same as us opening the file manager and then double clicking the X drive to move inside of the same. Now here what I want to do is, let's say, open a folder inside of the X drive, and I'll do that by typing the destination here because the X drive is messy. So okay, I'll use the X colon slash and then say I want to move inside of a doc directory like this. If I hit enter, you can see I am inside of that directory in the file manager. But if I want to do the same, I can just use the cd command again, pass it the folder destination, that is X colon slash doc like this. And if I hit enter, the prompt will change again to X slash doc like this, which is just the same as this one here. Now here you can see we have two text files, that is the file text and the list.txt. Now how do I know that from our terminal? To do that, we can use the list command that goes by the name of ls like this. And if I hit enter, you can see we get some output. That is, first of all, the directory we are in, that is the X slash doc. And then here you can see we have some more information. And for now, you can check this, that is the name and the file text and the list text. So we get some more information with the contents of the directory, that is X slash doc. So that's how we can perform some basic operations of just moving inside of directories and just listing the contents of that directory using the cd and ls command. In the next lesson, we will look at more terminal commands which can be used to perform more operations. So see you in the next lesson. In the previous lesson, we learned about the terminal and the different commands which we can execute on the same. Now back to our file manager, we know that we can create new folders using the right click, new, and the folder, which will create a new folder for us. Now, what if we want to do the same with our terminal? Well, we can do that using the mkdir or make directory command. That is, type out mkdir, followed by a space, pass it the path of the newly created directory, which we will create. So let's say I pass it a path like X slash doc slash new folder. This will go ahead and create a new folder inside the X slash doc directory. Now, as you can see, I typed out the whole path, that is from the X drive inside of the doc directory, create the new folder. This is called an absolute path. That is, we are referencing the folder location from the drive itself. Now here it's okay because we are not that deep. But if we were to be more deep in the file structure, then it would be a hassle to type everything from the X slash, then this directory, that directory, and then the location. To save us some keystrokes, what we can do is reference this current directory as a period or dot like this. What it tells is that we want to reference this current directory or the current working directory as just a period. So this will save us a lot of keystrokes. That is, we don't have to go our all way and type X slash doc and then new folder. We can just reference the dot and then our folder inside of that. This is called a relative path. Now, if we hit enter, you can see inside of the X doc directory, a new folder is created. We can verify the same using the list command, that is ls, which will list all the contents in our current working directory. That is, you can see folder, new folder, and the text files. Now, as you can see that the folders does not have an extension, that is, the text files has a .text extension, but our folder files does not have any extension. That's how we differentiate between files and folders in this terminal. To go inside of this newly created folder, we can use the cd command. That is, I will use cd new folder. Now we will be inside our new folder. As you can see, the prompt changes from xdoc to xdoc new folder. And as you saw, I didn't use the /thing. I directly referred as new folder. So if I refer cd new folder, it's the same as /new folder. So that's how we can use absolute paths and relative paths when we are referencing to the location of a folder or file. Now, how do we go back to our doc directory? Now, should we use something like cd doc or should we use something like cdx/doc? Well, the absolute path one works, of course, but if we do something like, let's say, we go back to new folder, and then if we do cd doc this time, we get an error. Now, that's the first error we encounter, so let's try to decipher it. As you can see, we have a proper message that is using the cd command, we cannot find this path that is x/doc new folder/doc because it does not exist. So that's how we read an error. Okay, don't get scared by just looking at this red text. Try to read it. It's just some plain English. Okay, so what it tells is that it tries to go ahead and find something like x/doc new folder and then doc because as I've told earlier, this doc or the plain doc means /doc. Okay, and the same is not available or the same does not exist. That's why we get an error. So as you can see, this dot refers to the parent, which is basically our current working directory. So what we can do here is that we can use two dots. And this two dots means the parent of our parent. Do you get what I mean? Let's enter the command and you can see we go back a directory. That is, here one dot means the current directory or our parent. And if we use two dots, it means the parent of our parent. That is, our x/doc new folder's parent is itself. But if we have the parent of its parent, it is x/doc, which is the prompt here. So we can use the cd ... to go back one directory. But it does not work if you do cd ... It will raise an error. So it's only limited to cd, two period keys or two dots. Okay, that's how we can use the cd to go back and forth directories. Now, you remember that we have the files. Okay, let's ls that. Okay, we have folder, new folder, and some text files. Now let's say I want to delete the folder file, that is this folder. To do that, we can use the rmdir or the remove directory command. That is, type out rmdir space, the name of the directory. Again, I'll be using relative path, that is just folder, hit enter, nothing happens, but we get no output, but something happens, of course. That is, the folder directory is removed. We can verify the same using the ls command. So I will type out ls, enter. You can say this time we only get new folder and of course the text files. So using the rmdir command, we can remove directories from our current working directory. Or of course, if you use absolute paths, you can remove directories from other drives or some other place as well. Just like our folders, we can also create new files. So back to our file manager, let's say we create a copy of file.txt. So right click, copy, and then we paste the copy here as well. Now we can achieve the same using Ctrl+C and Ctrl+V, but at the end, we will get this file-copy.txt, which is a copy of our file.txt. To do the same in terminal, we can use the copy or cp command. Type out cp, followed by a space, pass it the original file name, that would be file.txt, and then the file name which the copy would be created with. That would be, let's say, file1.txt. Now if I hit enter and then do ls, you can see that we have the file-copy, which was created using copy paste. Then we have the original file.txt, and then we have the file1.txt, which we created using the cp command. That is, the cp command takes the original file name and then the file name the copy would be created with. So now let's say we want to remove the copies because we just created them to show the purpose of the cp command. We can do that using the remove or the rm command, followed by a space, pass it the file name, which would be, let's say, file1.txt. Now if I do ls, you can see that the file1.txt is removed. The same can be applied for the file copy.txt. So let's try to remove it as well. File space copy.txt. Oh no, we get an error. Okay, let's try to read it. So you can see that we have remove item, that is our remove command. And then the message is a positional parameter cannot be found that accepts argument this. So what it means is that our command that is highlighted with the yellow color, and after that space we provide it a parameter. Parameter means the value, that is the path here. Okay, so here the parameter itself has spaces, which is why things gets messed up here. So if you look back, you can see that we have rm and then a space and then the path, which is the parameter actually, and it does not have a space. But if it had a space, then that means we are passing another parameter, which is in the case of our cp command. So what we can do is enclose this file copy.txt within quotes. So this way we will preserve the spaces as file name, not as separator between parameters. So we type out rm again, a space, and then the file name will be started with a quote. Then we type out the file name, that would be, let's say, file space hyphen copy.txt, and then we close the quote using another quote. And now this file name has the spaces preserved as well. Now we say that the file name starts here with the quote, and then we say the file name ends here with the quote. Now if we hit enter, you can see everything goes well. We can verify the same using the ls command, and you can see that the file /copy.txt is removed. So whenever our file names or folder names have spaces in them, try to use the quotes to not get an error. So now let's say we want to perform another action, that is moving a file or folder from one place to another place. Let's say in our file manager, we can do that pretty easily. That is, take this file and then move that inside of our new folder. So we can, let's say we want to do that in our terminal as well. So I will move it back to our doc directory, go back to the terminal. And now if we want to do the same, we can use the move or the mv command. The mv command takes the file path, that would be, let's say, file.txt, and then the location it needs to be. So we want to insert it inside our new folder. I pass it that, hit enter, and it's done. To verify the same, we can use the ls. So if I do ls, you can see we have only the new folder and then the list.txt. So I will go inside of our new folder using cd, and then I will do ls here, and now you can see it has the file.txt. Pretty cool. So we can move it back as well using again mv file.txt. And now what should we pass here? Right, we can pass dot, and then you can see something happens. Now what happens here is that we use the move command, file.txt, and the dot means the parent of our parent, that is just x doc. So if I also do cd dot and then do ls, you can see we have the file text back here. So not only we can use the period with cd, we can also use that for other places like this move command. So let's perform a really quick exercise to test the things we just learned. So what we do is create a backup folder and store the copies of our text files. So first of all, let's remove the new folder we have, and then we can create the backup directory. So mkdir, typos there, mkdir backup, and that's been created. Now we can do just ls to check the same. Okay, perfect. Now we can create the copy of our file.txt. So we will use the cp or copy command, then our file.txt, and then let's name it something like, let's say, file hyphen copy.txt. So note that I'm using the hyphen instead of a space. So hit enter, and now I have to move the same inside of our backup folder. I'll use the mv or move command, and then reference our file hyphen copy.txt, and then let's move it inside of our backup folder. Perfect. Now to check the things, what you can do is just list the directories or list the files of our backup folder right from our doc directory. To do that, we can use our plain old list command and then pass it the backup folder. Now, like before, we have used the ls bare, that is, if we use the ls like this, it will list the contents of the current working directory, but we can also pass it a directory whose contents it will list only. So if I do this, you can see it lists the contents of this x doc backup, which has a file copy text. Perfect. Now, what we did here is that, first of all, we created our backup directory with our mkdir backup. Then we created the copy of our file text using the copy command, and then we moved it with our move command. Now, we can pretty much do all this in one command. That is, we can do copy, and then we have the list.txt, and we can copy it inside of our backup folder directly here, and then just pass it the name, like let's say list hyphen copy.txt. Now this way it will create the copy inside of our backup folder. Now if I hit enter and then again list our backup directory, you can see that we have the list copy directly inside here. So using the copy and move was a bit long, but just using the copy command, we can achieve this feat as well. So it's up to you whether to use the copy then move or use the copy at once. Now we have our copies, and let's just ls the same. You can see we have the backup, the file text, the list text, and if we'll ls the backup directory itself, it has the copies of our text files. So that's how we can use the copy and the move commands to create something like this. So now let's say we want to rename the backup folder to something like copies because it's what it contains. So we can do this with the move command. How is that? Well, let's use the move command, then reference our backup folder. Now, instead of moving it anywhere, we will keep it here with a different name. Like we will keep it here as copies instead. Now, what will the move here do is instead of moving it anywhere, it will take the backup directory and rename it as copies. We can verify the same using the ls command. You can see that backup is renamed to copies. So that's how we can use the move to rename things as well. So now that's everything is done. Let's say we want to remove the copies directory with the copies in it. To do the same, should we use the rm directory or the remove command or the rm command? Well, here we will use the rm, and then we will pass an argument that is hyphen r and then copies. What this means is that we will remove all the directory or all the contents of the copies directory with itself. So if I hit enter, it will be removed. That is, if I do ls, you can see whole copies directory is removed with its contents. If I only do rm there something, then its contents will be spread out and only the directory will be deleted. Okay. So that's it for this lesson. We will learn about different terminal commands and also perform some different functions. Now, I don't think you have noticed it, but we are already coding. That is, instead of deleting a file, let's say we want to delete this file, we don't do right click, delete. Instead, what we are doing is we are going to the terminal and then using our commands. That is, let's say rm, which is a code word for remove. And then we are passing it the file name, like let's say list.txt. So it is the same as telling our computer like go ahead and remove the list.txt in the x/doc directory, but we are doing that using some code words or commands here. So that's what actually coding is. That is, we perform some task with some code words and as short as possible. That is, we don't do like let's say x/doc/list.txt. What we do is let's say either use period /list.txt or even remove that as a relative path. So as a programmer, we define or convey commands in short code words, and also even in that we perform or we become lazy and try to achieve the same result as short as possible. Like in the above case, you can see we copy the file using the copy command and then we moved it, but we were lazy. So what I told you is that we can perform those two actions in one command, that is just use the cp command, refer to the file, and then just move it directly inside of the backup folder. So I think you've got an idea of what programming or coding is with being lazy. So that's it for this lesson. In the next lesson, we will discuss about some more file operation commands. So see you there. In the previous lesson, we learned about the basic file navigation with our terminal. In this lesson, we're going to learn how to create and edit the contents of a file. Now, before we move forward, I would like to mention that some commands will only work on an Mac and Ubuntu terminal, not on the Windows PowerShell. That's why I have a Ubuntu terminal opened up here, that is a bash shell. I am doing so with the Windows Subsystem for Linux, or WSL for short. So if you want the same in your Windows terminal, I will leave an article or video in the resources. Now, before we move forward again, I would just like to mention quite a difference between the Ubuntu and Windows PowerShell, that is the ls command. In our Windows PowerShell, we can use ls. It shows our output like this, that is the last write time, the length, and the name of the files. Now, if we use the ls in the Ubuntu terminal, we get only the file names. So that's just quite a bit difference between the two, else except everything is the same. And of course, if you want more detail, you can use ls-l in the Ubuntu terminal, which will just display all the output or all the information, which is of course most of the time not needed. Okay, so the first thing is, how can we know the contents of a file? Now, if I move to my file manager, you can see we have our file.txt. If I double click it, you can see we have this content. Now, this is the notepad, and if you're on a Mac or Ubuntu, you will have a built-in text editor as well. So how can we know the same in our terminal? Well, if I switch back to our Windows PowerShell, we have the cat or concatenate command, which can display the contents of a file. And this command, of course, works on the Windows or Mac and Ubuntu terminals. So I can use the cat or concatenate command, pass it the file name, like let's say file.txt, and then hit enter. You can see we get the output. Now, this is the file we created back in the computers and data lecture. So, okay. Now we can also inspect the contents of the list.txt. So cat list.txt. You can see this is the contents of the file. If you want to verify the same, we can just open this in the notepad, and you can see this is actually the contents of the file. So that's how we can display or inspect the contents of a file using the cat command. The next thing is, how can we create new files in our or from our terminal? Of course, in our file manager, we can just do new and then text document or other file type if you want. In our terminal, or specifically in Mac or Ubuntu terminal, we can use the touch command, that is touch new file.txt. Now, of course, you can name it anything you'd want. Just hit enter and it will create it. We can verify the same using the ls command, and you can see new file.txt has been created. The touch command creates a new file.txt with no content. Now, if we can verify the same using new file.txt, concatenate its content, you can see we get no output. That is, it does not have any content at all. If we want to insert some content inside it, we can use the insertion operator. But before that, we need to look at what the echo command does. So first of all, the echo command, what it does is just echoes the output. Don't get what I mean? Let's see that. So echo, we give it some contents inside of quotes because our content may or may not contain spaces. So it's safe to use quotes. Okay, so let's say we pass some content like me, echo me. So we get me back as our output. So echo basically does is just returns some content you give it as the output. So what we can do is use echo some content and then insert it inside a file using this insertion operator or the insertion command. So let's say we want to insert the content inside our new file.txt. Hit enter and the content will be inserted inside new file.txt. To verify the same, let's go back to our Windows PowerShell and then cat our new file.txt. Now, because I'm using the same directory in the Windows PowerShell and the Ubuntu directory, so the new file is available here as well. So if I hit enter, you can see the content is indeed inside the new file.txt. So using the same command, we can also create new files from our Windows PowerShell. Now, of course, as I mentioned, the touch command does not work in our Windows terminal because the term touch is not recognized as a name of command letter function. So what we can do instead is use that insertion operator. We can insert some empty content inside of a new file, which will go ahead and create for us. So let's say we do echo and then no content inside of the strings, the insertion command, and then let's say we create another file dot text, hit enter, and if I do ls, you can see we have another file dot text. And of course, if we do cat another file dot text, there should be nothing in there. So that's a cheat or a way to create new files from our Windows PowerShell as well. But of course, you can use the touch command if you're on a Mac or Ubuntu terminal. Now, one thing about the insertion command is that it overwrites the contents of the file with the content provided. So let's say if I go back to our Windows PowerShell and let's say I have the contents of the file dot text, you can see it's code currently. But if I insert some new content inside it, let's say some new content using the insertion command inside of our file, the text, and now if I cat it again. So here, one cool tip is that let's say I want to bring up this command here. So without typing it, I can just use the arrows to bring it up. So let's say if I hit the arrow one time, it will bring up the upper command. If I hit again, it will bring up the command above it as well. So using the arrow, you can just bring up the previous history commands. So I will bring up the cat file.txt, and you can see the new is there. So that's just a step with our lesson. Now let's continue on our lesson. That is, you can see that using the insertion operator, the new gets overwritten in the file text because previously it had code inside it, but now it's new. So the insertion command overrides the content of a given file with the given output. Now the output can be anything. It should not necessarily be an echo command. It can be also something like ls. So I can just redirect the output of the list of contents in our working directory inside of our file. The text, hit enter, we don't get the output, but the output is redirected or inserted inside of our file.txt. So to verify the same, we can concatenate or view the files, and you can see we just get an output like ls. Now, of course, it may look like we just use the ls command, but that's actually the contents of our file.txt. Now again, as you can see, the new word was removed or overwritten with the given output. So if we don't want to do this, let's say we have our cat list.txt and we want to add something in this file. So in these situations, we can use the append command. That is, let's say I have something like echo. Let's say I want to add something like banana inside our list. So I will use the append command, that is 2 less than signs, and then of course our list.txt, that is the file name, hit enter. Now if I cat the list.txt again, you can see we have milk, egg, bread, and then banana. So the contents does not get overwritten. Instead, we get a new item added at the end of the file. So that's the difference between our insertion command and the append command. Now you can use them according to your situation. But when it comes to editing files, nothing beats the text editors, right? Like let's say if I open up this list.txt in our notepad, you can see I have the cursor, which I can use freely inside. Let's say I want to change this to milk, and then let's say I want to add another banana here, and then I can mess around with the cursor a lot. So how can we edit our file with a cursor like this? So first of all, let's close the notepad. And then if I go back to the terminal, I can use the nano command line editor, which is a similar application or terminal application similar to our notepad. Now, of course, that is only supported in the Mac and Ubuntu terminal. So I'll be switching to the Ubuntu terminal, and then I can use the nano command, nano, N-A-N-O, and then pass the file name. That would be, let's say, list.txt. Now you can see it opens up an terminal application similar to the notepad, where we have the contents of the file, the name of the file, and then some shortcuts which we can use to help us. So here you can see we have a cursor as well, which we can move freely inside of the contents. So let's say I can change it to something like languages, and then I can just edit this, let's say Python, and then something like Java, HTML, and then remove the banana. So now I have edited the file, and you can see the modified word comes up here. So now I want to save the changes. To do that, first of all, what we need to do is exit out of this application. To do that, we can hit Ctrl+X. Now you can see here we have the help, that is a upper arrow and X. This means Control for Windows, Command for Mac, plus X. So if I hit Ctrl+X because I'm on Windows, it will bring up this confirmation message, that is, do you want to save the modifications? If I hit N, that is no, it will close the terminal application without changing the saves. But if I hit Control C, then it will cancel this and I can just go back to editing the file. So if I do Control C, you can see I can again go back and edit the file. Okay, let's go back to that. So I will go Control X again. And now I want to, of course, change the saves. So I will hit Y on my keyboard. It will bring up this confirmation dialog where you can edit the name or the file name. So here it's list.txt. I can change it to something like new list, etc. And of course, if you want, you can just leave it to be or what it was actually. And then after, if you have edited or not, you can just hit enter and then it will save the file. So now we can verify our changes with the cat command. That is, I can just write in cat list.txt and you can see our changes are, of course, saved. So that's how we can edit or create files with these commands. And of course, some commands only run on the Ubuntu system and some work with the PowerShell as well. That's it for this lesson. See you in the next one. So you hear the term internet for the first time and imagine something like a fishing net or so. But why do you need a fishing net? That's not what I'm getting at here. By internet or by simply net, I mean a network. Think of it as a conversation between people, that is, one asks something and the other responds with an answer. Let's say you want to watch a movie called Banana on your smartphone while traveling, but it is in your computer. How do you get in on your smartphone then? Well, get an USB cable, hook it on your computer and smartphone, and then get the movie. Easy, right? We know how processor view data, that is zeros and ones, and the Banana movie is really big. Oh, I mean it's over a gigabyte, so around this much zeros and ones are traveling through the thin USB cable. So it makes sense if it takes time. Now, what you did here was a really basic example of a network. You created a server, that is your computer, which is giving the banana. And there is a client who is taking the banana. Okay, let's get serious now. When there is a transfer of data between a server and a client, it is called a network. Here, our computer is the server which is serving the movie on the request of the client, which is your smartphone. The movie is transferred through the USB cable, and after some time, you have the movie on your smartphone. Now you can watch the movie while you're traveling as well. Note that the transfer of data can take place with wire or without wire, that is wireless as well. Okay, having fun in the vacation and you're fully refreshed. But there is a problem. You don't have any content to watch during your back trip. You suddenly remember that you can stream content online, but how do you do that? Which cable you need to plug in to be able to stream the content? Well, you open Google, search for Banana 2. In the results, you open a website named banana2.com where you watch the next release of the movie online. Great! Now you're wondering actually what happened behind the scenes, right? Let's take a look. You search for Banana 2 movie and it sends a request to Google servers to show results for that query. Now Google server sends back you a list of results for your query. In the results, you choose to visit banana.com, which in turn sends a request to the Banana 2 server and it sends you back the Banana 2 movie. Enjoy! One thing to note is that when you requested the Google servers for search results, you also send data, that is the query. So as a client, you send data too. So you connect it to the Google network to get search results for Banana 2, and then you connect it to the Banana 2's network to get the Banana 2 movie. Here, the network is not as simple as it was before. It is an interconnected network of different networks. While you use your cellular network, or commonly referred as mobile data, for connection, this is a wireless mode of connection which also includes Wi-Fi or wireless fidelity. Using the request and serve, the whole internet is working. This much may be already overwhelming for you, but there are people who specifically do handling requests or serving content, that is through code. It is called network scripting. There are protocols, IP addresses, domains, and many more things. If this piques your interest, then you can be a network engineer. If not, it's fine to be a programmer. There will be times when you don't understand something, or you may get stuck on a coding exercise or another problem. At those times, you can always count on me and the community to help you out. You can join our Discord server, which is a community of learners just like you. You can join for a general chat or just ask your queries. Whatever the case is, make sure to join the community to get the help when you are in need and help others when they need it. Now that we have learned about the computers, the bits and bytes of data, programming languages, and also perform some actions through our terminal, we can get started with programming. What we'll do is we'll write Python code, which will be translated by Python interpreter into machine code, and then it will be executed by our CPU, which will generate the output. Now, first of all, we need that Python interpreter in our system. So open up your browser and then visit python.org. If you want, you can read further here, down here, else just move on to the download section. And then as you can see, we get the download the latest version for Windows. If you're on other platform like Mac OS or Linux, you will get that. At the time of recording this video, the latest version is 3.10.1, which is I'm going to use in this course. So go ahead and download it. Now that we have downloaded the Python interpreter, the next step is where will we write the code? Well, of course, we can use the old plain notepad, but that does not feel good. If you have seen any programmer coding before, they've used special code editors. So we will use a special code editor, that is VS Code, offered by Microsoft for this course. And if you have or any experience with other code editor, you can go ahead and use that. But if you have not, head over to code.visualstudio.com and then install the setup for Visual Studio Code. Okay. Now, after everything is finished installing, we will install them one by one. After they have finished installing, open the downloads folder or where they are downloaded. So downloads, typo there. Okay. So we have the VS Code setup and the Python interpreter. So let's install the Python interpreter first. You can see that we get an option like this. And whatever you do, make sure you check this add Python 3.10 to path. This will allow us to execute the Python command from our terminal. And then just hit install now. And then it may take a bit of seconds. So wait for it to finish installing. After it's finished installing, you will get this setup was successful message. Okay, close that. And then now we can install the VS Code as well. So double click the same and then install it like any normal software. Now that we have installed VS Code and Python interpreter in our system, go ahead and launch Visual Studio Code. And of course, you can either uncheck this and launch it manually. I'll just keep it checked. This is how Visual Studio Code should look for the first time when you open it. Now, as you can see, the font size is really small, so you can increase it by hitting Ctrl equals on your keyboard like this. Okay, this is much better. Now you can see we get it gets started with VS Code message or tab like this. Here you can choose the look you want, and if you want you can go through these steps. So the main thing is that if you want you can either switch to a light theme or dark theme like this. So either you can go back to light, or if you want you can keep dark. So I'll be using the dark theme, and then let's remove this. Now before moving forward to the UI, let's just install the Python plugin inside of a VS Code so that we can get a lot of features when we write Python code. So here you can see the extensions tab. Just click on it. It will open the extensions panel. Here just search for Python, and then it will bring up this window. So the Python with the Microsoft stick, go ahead and open it and install it on your VS Code. What it will allow you to do is run Python files with a click of a button and also some other great features. After it's finished installing, close this tab and also click this tab, so this tab will go back to where it was. Okay, now we are back where we started. So now we can go ahead and open an folder in our computer where we will create Python files. So click on the file and then open folder and then navigate to any place, and it's better if it's empty. So I'll go to our guinea pig directory, that is the X dog directory, and then you can see I'll just select this folder and you can see it's opened up. Now in your VS Code you may or may not get this message, that is, do you want to trust the authors of this folder? Of course it's me who is written, so it's fine, but it should not be a problem in your system as well. So you can just do trust the authors, and yes, I trust the authors. Okay, so what you get is again the get started page. I will close it for now. And then what you get is the file manager or an explorer thing. Here you can see is an app.py. So this is the list of contents in our dog directory, and currently it's empty. That's why we only have the app.py. I mean, not empty, we only have the app.py inside of our dog directory. If we want, we can add more files with this plus icon. And if you want, we can delete files as well by just right clicking on them and then hitting delete. And yeah, move to recycle bin. And let's say I just create a new file. So let's say file.text, and this is a text file. If I want, I can write anything I want because this is the text editor window. So if I close it, and then you can see if I click it, this window pops up where we can edit the contents of this specific file. So you get the file name on the tab and here as well. So I can just write freely I want, some freely written text. Okay. Don't save. Now you saw that if I want, I can save the changes, and if I don't want, I cannot change the saves as well. So let's go ahead and create a app.py file. And here, let's say I can write anything else I want. So it's just like a plain text file. So yeah, some. But as you can see, when I type, I get this drop down. What is this? Well, when you search or in the search bar, if you type something, you get some suggestions, right? This is something like that. That is, VS Code is telling us I may be writing this word or this word or this word. So if I click on, let's say I was writing this word, and if I hit enter, you can see VS Code enters this text here. So it's like an auto completion for our code. Actually, it is that we are lazy. We will not be typing this much text. So we just, okay, I write support and it comes here, supports get item. I click enter and that comes up here. So that's we being lazy, or you can say one of the cool features of VS Code. Okay, so let's remove everything. So let's move on to the next lesson where we'll actually write some code here. When learning any language, spoken or programming, you need to learn how to form it. What I mean is that written spoken languages like English follow some specific rules which we call its grammar. Now, if I write a sentence in English like I'm going to learn Python, here we are using special rules like the subject me comes first, then comes the verb going to learn, followed by the object Python. If I don't follow the grammar, then I will write something like Python me learn. This is called grammatical error. Like the order of subject and object is incorrect, learn is not even an English word. If I text this to anyone, it's unlikely that they will understand my intentions. The same applies to programming languages. Each programming language has its own set of rules, which is called syntax. While writing code, we need to follow the syntax. Also, like words, Python or programming languages use special keywords to express different intentions, like the learn word here. So we need to learn the syntax of Python to be able to write programs in it. Let's learn the same with an example. Let's say we need to find what's the product when 8 is multiplied by 21. The problem is stated in plain English here, which we understand of course, but now we need to write the same in Python to forward it to our CPU. So let's get back to VS Code and open a Python file. As you can see, I have enlarged the font size of the UI so that it's clearly visible. Okay, so now let's create a Python file. I will click on this icon and then let's name it app. And then to create a Python file, we end it with the .py extension like this. So like the text files end with the .txt extensions, Python files end with the .py extension. Hit enter and it will create the file. Now you can see that this Explorer is covering half of the view. So what I can do is just click on this Explorer icon or hit Ctrl B on my keyboard. So the Explorer will go back and we'll have more room for our editor here. Okay, so now we want to find the result of when 8 is multiplied by 21. So in Python, we can do that by just typing 8 multiply 21. And that's it. That's the simplicity of Python. As you can see, we just wrote 8, which is an integer data type in Python, which we'll get to later. Then we have the star or the multiplication operator in Python. And then we have the 21 integer again, just like 8. And this is called an expression, which will evaluate to the product of 8 and 21. And now you can see that we have a white dot here, which means that we changed the contents of the app.py, which is, as you can see, we entered these contents, but didn't save it. So to save the file, we can just hit Ctrl+S, which will save the file. And if you want that to be done automatically, what you can do is come to the file. And then here we have an option called autosave. And here you can see under file, we have the autosave option. If you click that and make any changes to the file, the changes will be saved automatically. So I'll make sure to keep that checked because I often forget to save a file. Okay, now let's say we want to run this Python code. That is, change it into the machine code and get executed by our CPU. To run the Python file, what we can do is click on this play button, which is added by the Python extension we just installed in the previous lesson. So if we click on this file, you can see a terminal pops up in VS Code. So this is just like the Windows terminal we had in the previous lessons, but it is built right into VS Code. Okay, you can see that the prompt is xdoc, and then we have a green or yellow text path that is C users, Rahul, app data, local programs, Python, Python 3.10, python.exe. That is the absolute path to the Python interpreter. And then we have the x/doc/app.py, which is our Python file right here. So we can actually get away with relative paths here as well. That is, when installing Python, we checked that Python should be added to the path. And what it will allow us to do is use the Python command in the terminal like this, and then pass it our Python file like this. If we hit enter, it's just the same as what happened before. Either way, you can use the Python command and the file path, or use the plus button here or the play button here. Okay, so as you can see that when we execute the Python or our Python file, it does not return any output. Well, why is that? Well, unlike the ls command, which returns us the output of the list of the contents, in Python code, we can control the output and input ourselves with code itself. So in Python, if we want to display an information or return an output to the terminal, we can use the print function. So we type print like this, open and close parentheses like this. We will take our expression, that is 8 multiplied by 21, and then insert it inside of the parentheses of the print function. Now, if we run the program, you will see we will get the output, that is 168, that is the product of 8 and 21. So here, just like the terminal commands, print is a function in Python or a built-in function in Python which performs a specific task. And that task is take the value of whatever is given inside these parentheses and then return that as an output in the terminal, that is 168 in this case. So here we passed the 8 multiplied by 21 inside the parentheses, which is the print function. Phew, that was a lot, but we actually were able to create a simple bare bones Python program which is actually able to do something, that is find the multiplication or the product of 8 and 21. Now, I mentioned it before that this 8 here is an integer data type in Python. Now, what's that? Well, in the next lesson, let's learn about more Python data types. So, see you there. Now, before we move forward to Python data structures, let's talk about data structures in general. So, what is a data structure, right? Everything from your academic results to your recent online order is a data which holds value and hence needs to be stored. There are billions of people worldwide whose data is stored like this every day, billions or even trillions of time. Now, if we don't store the data structurally or properly, it will become a mess in no time. Imagine finding the meaning of a word from a dictionary if it is not sorted by alphabetical order. A data which is created and stored in a structurized or organized way to perform various operations on it is called a data structure. For example, you're asked by your dad to write the number of a client on phone. You will pull up any notebook near you and write down the number. This is a data. If you're smart enough, you will ask your dad for the person's or the client's name as well and then write it beside the number. This is called a structured data. When your dad asks for the number of the client, you can give him the number easily. Now, if you had not written the name beside the number, then you'll be unsure whether or not it's that client's number. But writing the name beside the number will ensure that it's actually that client's number. Now, for CPU, it is only zeros and ones, but using higher level programming languages like Python, we can structurize our data into different data types. In the previous lesson, I mentioned a data type called int, which is called an integer. In Python, it's represented as only int. It's the name given to all the integral numbers which lies on the number line, that is from -infinity to infinity. Now, it's only one value data type, that is, it is just a number. It will be either 12 or 8 or some other number. But what if we need to store more values at once? Data structures which contains more than one value are called arrays. Let's say you're counting the numbers from 0 to 4. That will be 0, 1, 2, 3, and 4. This is an example of an array. In Python, we have several data types which can be used to create arrays like this. So let's hop onto VS Code again and see these data types in person. In the previous lesson, we learned about the integer data types. That is, if we want to write any number, we can write it like this, just as plain as it is, let's say 19 or 104. So this is called the int or integer data type in Python. Now, what if we want to store or write the name of some person like John? That is a textual data. So do we just write it like this? Well, as you can see, VS Code is highlighting that there is something wrong with it with the yellow squiggly under the name. If I hover over the same, you can see what is the error message. That is John is not defined. So plain text like this is interpreted as an variable in Python. Now, of course, we'll get to that later, but this is not what we want. That is, this is not a textual data type. To create textual data types in Python, we need to create a string. To create a string, we can either use single quotes like this or double quotes, and then inside of the quotes, insert your content. That would be John here. So we start a quote, then insert our content, and then close the quote. And this at all is called a string data type. Okay, while we're talking about textual data types, what if we want to just add some comments or note inside of our code, which is of course meant for us to read? Well, programming languages introduce a concept of comments. That is, we can add some pieces of text inside of our code which is only meant for us to be read, not any data type or not any code. So in Python, we can do the same with using a hash and then writing anything. Like let's say this is a string. I just want to denote myself that the thing I've written here is a string, and I do that with this comment, and the line is prefixed with an hash here. So note that the color of the two is different. That is code highlighting done by VS Code. So here this is a data type which is of course interpreted by the Python interpreter, but this line will be ignored by the Python interpreter because this is not meant to be any code, so it will not be translated into machine code. Instead, it is only there for us to read. That is, as it says, it's a comment. Now, of course, I can move the same after this line as well, like this is a string. Now, this is an inline comment, so either you can have a comment like this or the one we had before. Now, adding comments help to make your code more readable. Of course, you should not overdo it as well. So this is how we create strings in Python to store textual data types. Now let's say if we just want to say yes or no in some situations. For those, Python offers the true and false data types, which is a bool or boolean data type. In Python, we can use them to define as they sound. That is, let's say if I want to just say true to a situation, I can just use the true keyword. As if I want to just say false, I can use the false keyword instead of creating them inside of strings like this. So they are Python keywords, and there are a total of 35 keywords, which we will discover along the way. Now, let's say if I want to store a data type like my shopping list, which has milk, egg, and bread inside it. So do we create them inside of strings like this? Well, as you can see, it does look like a string, but how do we differentiate between a normal string like the John here and this string which has some more elements? For this situation, Python offers sequence data types like the list data type here. To create a list in Python, we can open and close square brackets. Inside of the brackets, we can insert a element, like let's say the first element is milk, and then if I want to add another element, I can separate those elements with a comma like this. Okay, another element goes egg, and now if I want to add the bread element as well, I will again use comma, strings, bread. So this is a list data type in Python. That is, we open a square bracket, insert the elements, separated by a comma, and then we close the bracket. Now, let's say your dad asks you to store the numbers of your clients in phone again. So what you will do is create a list and then write down the numbers, like let's say 99021, okay, 98761, and then again 99304. Okay, so this is a use case of list where we just stored the numbers of some clients like this inside of, again, box brackets separated by a comma, which is called a list data type in Python. Sometime later, your dad comes to you and asks for Dale's number. Who's Dale? He tells you that one of the client's name is Dale and one of the above is his number. Now in a hurry, you forgot the names and now you can't find the information for Dame. The same is happening with Sam now. That is, when his dad says, hurry up and note down this client's number. Sam replies, wait, let me open up VS Code. So how will you store the data of client's number with their name? Well, for that, there is a special data type called dict or dictionary in Python. So instead of box squares or box brackets, we will use curly braces like this. And then we will have a key, that is the name in this case, like Dale. And then we will assign a value to this key or our name, that will be the information, with a colon like this. And then the value, which is, let's say, 99021. So let's inspect the code to see what actually we did. So here we first of all opened a curly brace. Then we created a key, which is the name in this case. Then followed by a colon, we assign it a value, that is 99021 integer in this case. Unlike list, it's clearly visible that this value is being assigned to Dale key. Now, using commas, we can add more key value pairs like this. So let's say if I add another key value pair, like let's say Kyle, and then the value for that would be 9671. Now Sam can store all the keys like this and have no problem when he wants to read it back. So it's great that we created all these different data types, but actually how do we store them? As you can see, the data type is just lying around in our code or our file. To actually store these data types, we need to create a variable. To create a variable, we just write the name of the variable, like let's say contacts in this case, and then we use the assignment operator like this. So what we did here is that we assigned the contacts variable with this dictionary using the assignment operator. So now we can access or reference to this whole dataset just using our contacts variable. To test the same, let's use the print function we learned in the previous lesson. So I will use the print function and then I will pass the contacts inside the print function to print the contents of our contacts variable. Now let me open up our terminal, and here let me just make sure everything's clear. Okay, Python app.py, it will run our script. I'll hit enter. You can see we get the same dictionary printed on the terminal. So using variable names, we can access or denote a whole dataset like this. That is, this whole dictionary is stored inside of our contacts variable. And now later in the code, we can access this whole dataset using this contacts name or variable. So let's summarize what we learned in this chapter. That is, first of all, we learned about all the data types, like we can create int using just the int reference, like let's say 9 or 12 or 109. Okay. Then we learned about the true and false values, that is the Boolean data types like true or false. Then we learned about the list data type, which can be used to create lists. Like let's say I will just use box brackets. Inside of that, I can have multiple elements, like let's say 1, 0, 1, 2, 3, and 4. Then we learned about the dict data type or the dictionary data type, which can be used to store key value pairs. Like let's say we have a key and then we have a value for that key. And we just demonstrated that using the key like the Dale, and then the value would be the information of that key here. Also, to store these data types, we can create variables, like just type out or just give the variable a name, like let's say contacts in this case. Then using the assignment operator or the equality operator, we can just store any data type to it, like let's say the 99021 here, or even a dictionary if you want. So that's it for this lesson, where we learned about the different data types in Python and how to create variables to store the same. In the next lesson, let's learn about the operations which can be performed on these data types. See you there. In the previous lesson, we have learned about the different data types in Python. Along the way, we encountered the problem with Sam that he needs to store the contact information of his stats clients with their names. Then we learned about the dictionary or the dict data type, which we use to store inside a contacts variable for later in reference inside the program. Now Sam's dad asks him about Tim's contact information. Sam pulls up the terminal, runs the Python file, and reports his dad back. His dad got impressed of Sam and thought his kid became a hacker when he used the terminal. Now it may have been good for Sam's dad, but not for Sam. His dad keeps him telling to note more and more numbers, and Sam ends up with a very long dictionary like this. As you can see, there are a lot of key value pairs, and you can see that the dictionary looks unusual. That's because I've just formatted it. That is, what I did here is, let me show it. Let's say we have the contacts dictionary again. And here, if I just hit enter, you can see something like this happens. That is, the new line comes in. And that is formatting done by VS Code automatically. And then we can just type in, let's say, Dale, and then the key value pair, whatever. Okay, so that's how the formatting is done. Okay, coming back to our key value pairs, you can see there are a lot of key value pairs. Now, if Sam wants to find the key of, let's say, Mr. Jack, what he have to do is just find it like hunting. That is, let's say Dale, Tim, James, Wilbur, Thoms. Okay. Now here is Jack. You can see. So what we are literally doing is just hunting for the value from the long dictionary. Of course, it's doable, but it's not the efficient way. In the previous lesson, we learned that data structures are created and stored in a way that we can operate on them later on. Just like the same, Python dictionaries allow us to access any value using its key, using the slice syntax. So let's see, how can we do that? So first of all, what we need to do is refer to the dictionary that is stored in the context variable. Then we need to open and close box brackets like this. And then inside of the box brackets, what we need to do is pass that certain key. So let's say we want the data for Jack. So we pass that key inside of the box brackets. And now this whole expression will evaluate to the value of the Jack key. We can verify the same using the print function. So print what is the value of Jack in the context dictionary. So let's pull up the terminal and then run our Python file. That is python app.py. Hit enter and you can see we get 99116 in the terminal. That is the value of Jack. To verify the same, you can see Jack 9116. So using the slice syntax, we can access the value of any key using its key, of course. So what we did here is first of all referred to the context dictionary. Then we open and closed box brackets, and inside of the box brackets we passed the key, and that's it. Using the slice syntax, Sam can perform his tasks pretty easily. That is, if his dad asks for the contact information for Mr. Wilbur, we will just pass that as the key here, and then he can run the Python file, that is python app.py again, and we'll get the information. Now, one thing if you note here is that we are doing two things. That is, first of all, we have to come to the file, then change the key here, and then run the Python file. Of course, it's already efficient, but what if we can just run the Python file from the terminal, and then we can just pass the key on the terminal and then get the value of it? Well, of course, it sounds interesting and it's doable as well. So let's see how can we do that. If you remember in the first lesson, I mentioned that in Python, we can control the input and output from the terminal with different functions in the Python code. So if we want some input from the terminal, we can use the input built-in function. Like the print function, its job is to get some input from the terminal and pass it back inside our Python code. So let's run the code as it is. So if I hit python app.py, enter, you can see that the cursor moves to the new line and just freezes there. So what it's waiting here is for our input. So if we type something like, let's say banana, and then hit enter, you can see we get our prompt back, that is the PowerShell prompt. And here the banana text just keeps here. So what we did here is typed out the banana from our keyboard, which was the input through our terminal. Now, of course, we didn't catch the value. That's why nothing happened. So let's say if we want to catch the value, we can just store it inside a variable like our dictionary. So let's say we get our, let's name it something like imp, and the equality operator, which will return, that is our input. The thing which we enter here will be stored inside this input variable, and then later on we can access it. So let's say I'll just print it back. That is you passed, and then let's say I'll just you passed this input thing. Okay. I'm just adding the spaces so that it's easier to view. Let's make it a bit small so that we can view our whole code. So, okay, we call the input function, which grabs the input from our terminal, whatever we type, and then that is stored inside this input variable. And then we are just printing it back to verify that we have that value instead. We have that value actually. So now in our terminal, let's run the program again. I will type in something like, let's say, again, banana. And then you can see in our terminal, let me expand it. You can see we get you passed banana. So that's how we can use our input function to grab some input. So using this input, we can just take the, you can say, the key for the client and then just return it back using the slice syntax. So first of all, what we do here is that client equals our print function. Oh, sorry, it's input function. We'll get the client's name and then we will just print the client name back. That would be contacts. And then inside the box brackets, we'll not pass a key. That will be a dynamic value passed inside our client. So just pass the client here. And now if we run the program, that is, let's bring up the terminal. Let me just issue the clear command and then python app.py. So let's say I want the key for Mr. Thomas. And you can see we get the value printed. And this is already cool. That is, now we don't need to come to the file and then edit the name of the slice syntax. Instead, we can just pass it as an input here, and then the Python program will just return it back. So it's really cool that we can do this already. But again, there's one more demand. That is, when we run the program, you can see that the cursor just freezes there. Now, of course, we know what's happening here, but from an outsider's view, it's a bit weird. That is, why is it freezing there? So here instead, what if there was a message like the search term or the client name, etc., where we could have passed the name like we see in form fields? Well, that is called a prompt. Like we have the prompt here, which we pass the command as. We can do the same here as well. That is, let me just pass something so that the program stops. So I'll again pass Thomas. Okay, let's close the terminal. And here, this input function receives a prompt that would be a string. So let's say I will just pass search and then like this. So also let's insert an emoji so that it's more cool. Okay, goes our emoji there. So you can see what we did here is that to our input function, we are passing a prompt. And sorry for the dialog box there. So we are passing a prompt that is search this. And now what will happen is that if we run our program again, let me clear the terminal and then bring up the command. You can see we get the prompt that is search with our emoji. And now we can just pass in our search term. That would be, let's say, Wilbur. If I hit enter, you can see we get the term. That is our Wilbur's information. So that's how we can use the prompt inside of our input function, which will return the client, and then we'll just get the client. Inside of our contacts, we use that to slice that client's value and print that back. So now Sam and his dad both are happy. So one more thing which we can improve here is that when we are printing the contacts information or the client's information, we can also print the client's name. So here in the print function, we can pass more than one value by separating them with a comma. So here, let's say, first of all, we want to print the client name, which will be the input. And then with a comma or after a comma, we'll print the information like this. Okay, so let's run the same to test the same. So I'll just type in again Python app.py and then let's insert, let's say, Wilbur, and we get the information, and now it's more readable. So we have created a really small phone book application with Python. And of course, this is our first application, which looks cool. So the next thing is when we create application, there will be some times where things will go wrong. Didn't get what I mean? So first of all, let me expand the terminal like this. And now let's clear the screen. Now I will again run the Python file. And here let's pass something that's not inside the dictionary. So let's say I'll pass something like banana, and then you can see we get an error. So don't freak out. So this is the first bug we have encountered since we started Python programming. So in the next lesson, let's see what is this bug or error and try to find out how can we solve the same. So see you in the next lesson. So why did the program cause an error? To find out the same, let's inspect the traceback given by Python. So first of all, what happens is that to our search term, we pass banana. And of course, there's no banana in our dictionary. So in the traceback, it also mentions the file, that is our app.py, which is inside of this directory, that is the absolute path. And it also mentions the line number, that is 19, and whose code is this, you can see. And in this code, we try to print the client and also perform the slice in this context dictionary with the client. Now here, the specific error raised is key error, that is, when we try to search or when Python tried to find the banana key inside the context dict, it failed to do so and hence raised the key error. So we didn't take this into matter that banana can be passed as a search term, and of course it will raise an error when we try to slice the same. So what we need to do is safeguard our application from things like this. That is, if a search term is not inside of our context dictionary, we will just print a message like not found. And if it is, we will just print the information on the same. It sounds good, but how do we actually implement the same? To do the same, we need to use Python's if statements. So let's delete this piece of code for now. And what I'll do is use the VS Code's folding. You can see there is an arrow just right beside contacts. Because this is too long, you can see a line running here. If I click on this, it's minimized. So now I have more room to work in the space and also view from the first file. Okay, so now first of all, what we will do is use or see how the if syntax is written. So we will use the if keyword and then a condition. And then what we'll have is a colon to define a block of code. And for now, it should be just a comment. So what we have here is the if keyword. Then we have a condition. And to test the same, let's say we will just write a print function. And the message will be, let's say, 1 is bigger than 0. Now, of course, I don't have any logic here. That is, if I just run the program, that is python app.py, you can see the line is printed. But let's say I want to make sure actually 1 is bigger than 0 so that it's printed. So we can use the if statements. So I will just write the if statements and then create a condition. To create a condition like 1 is bigger than 0, we can use the 1 integer and then the greater than operator, which can be used to build conditions like this. Then we will have the 0 and then again the colon to define a block of code, because here we don't want to run a statement normally. We want to run it if this if statement is true. That is, this 1 is bigger than 0. To find the same, let's just print it. That is the condition. Now it's also an expression in Python. Let me just insert the spaces so that's easy to view. You can see I've just created the condition 1 is bigger than 0. And now if I just clear the terminal and then let's make it small so that we can also view the code. So if we print that is 1 bigger than 0, so python app.py, oops, you can see we get true in the terminal. So if the value or the condition evaluates to true, we will execute the given block of code. Else, we will not do that. So we can do again, if the condition, that is 1, is bigger than 0, then to define a block of code, first of all, we will denote that or start the block with a colon. Then we'll move on to a new line. And you can see VS Code adds 4 spaces automatically. This is called a block of code or indenting a code. You can add the same with your keyboard, that is just remove the spaces. And then if you hit tab on your keyboard, it will insert 4 spaces or a tab space. Now we can write our code that will be the if block. So I'll just insert the print statement we wrote before, that is 1 is bigger than 0. Okay. Now, if I run the code again, that is bring up the terminal and python app.py. So you can see we get 1 is bigger than 0 printed on the terminal. Now, if I just reverse the condition, that is 0, is it bigger than 1? Of course, it is false. And what do you think will happen if we run the Python program? Well, we will get no output because 0 is bigger than 1. This condition evaluates to false and this if statement does not execute this given block of code that is indented. So now you may have got why we have indented this block of code, because this is a piece of code which should be executed if this statement is true, which we do of course with the if keyword. Now let's say we want to execute a block of code when this is false. We can use the else keyword for the same, and note that how readable they are. That is, just if this condition is true, we will print this. Else what we can do is print 0 is not bigger than 1. So 0 is of course smaller than 1. Now if I run the code, we will get the else statement printed on the terminal. So here let's inspect the code again. That is, we create an if statement which has a condition. If this condition is true, we will execute this block of code. If this condition is not true, we will come to this else statement and execute this block of code. Of course, it's up to us. That is, we can give the else statement or not give it as well. So now we can use this whole logic in our program, that is our phone book application. That is, first of all, we will get the client. Again, I'll just write out the code, that is input, and then we will have the search. And then I will have an if statement to check whether or not this given client is inside of our contacts. To build a condition like that, I will refer to the client first of all, and then I will use the in operator and our contacts dictionary. Note how readable is this condition. That is, if the client is in our contacts, we will just print the client's information. Okay, so now let's slice it out. So we will use contacts. Then we will just give it the client key. And then in the else condition, if the client is not inside of our contacts, we will print that the client is not found. So client not found. Okay, so you can see just using a simple if statement, we can safeguard our application against errors. So let's run some test cases so that we can check the same. Let's clear the terminal and then run the application, that is python app.py. Okay, let's pass it something like, let's say Jack. Okay, it's there. Now again, I'll run the application and search for something like, let's say Kyle. Okay, it's there as well. And let's say we will pass banana this time. And you can see we get a message instead of the error, that is banana not found. So look how cool is that, that instead of the error message we got earlier, we are handling the error and printing an appropriate message. So using simple if statements, we are able to achieve the same. So now what we can do is just open up our terminal, then run our Python script, and then we can just pass it the name of our client, let's say Thomas, and then it will return its information back. Great, we actually built an application to which we can pass our client's name, which will return its information back. Of course, if there is no information for that client, then we will not get an error. Instead, we show an appropriate message. I'll leave the source code in the resources for your inspection. See you in the next lesson. We have made quite an progress with the program we created over the past few lessons. But there might have been some questions still lingering in your mind, like what are functions like the print function, and why did we use parentheses with them like print parentheses? In this lesson, let's discuss about these things. So what are functions? Simply put, functions are block of codes that can be executed more than once using a reference name like print or input. To understand them better, let's learn how to create functions ourselves. Python allows you to create functions pretty easily. using the def keyword and following the function declaration syntax. To declare a function, we need to use the def keyword and then name our function. So let's say I'll create a fire function, and then we need to use parentheses because it's not a variable name. Instead, it's a function name. We write out the name, and after the name, we insert parentheses like this. And then to start the block of code, first of all, we use the colon, and then by indenting the block of code, we just define its block. To declare a function, we use the def keyword, then we give it a name like fire here, and then after the function name, we use parentheses, and after that, we define the block of code by starting it with the colon and then defining its block of code. So I can insert some print statements for its block of code. Of course, our fire function is just a bunch of print statements, but it'll be a fun exercise to play with. So here now, if I run the file as it is, so let's open up the terminal, and then if I just execute the Python file, you can see that we get no output. That's because we have defined the function, not called it. That is, you can see that I have defined this fire function with this block of code. So our fire function is saved in the memory with this piece of text or this piece of code, and now we can call it whenever we want. In the case of its statements, its block of code got executed if the if statement evaluated true, as it was not. But with functions, we can execute whenever we want using its calling syntax, and by calling, I mean executing its block of code. So to call a function, we just reference its name like this, and then we type out parentheses, which will call the function for us. So now let's pull up the terminal and let's make some space for the terminal because there will be some print statements. Okay, let's clear it first so that we have enough space. So I will bring up the Python command, execute it. You can see we get the print statements printed on the terminal. So to call a function, first of all, just reference its name and then add the parentheses after it, which will execute its block of code, that is these print statements. Thus, we get this output in the terminal. So what we did here is that using the def keyword, we defined our fire function, and then after defining it, we called it with just the parentheses. But one thing to note here is that for the print function, when we call it, we are also passing it some data, that is the loading ammo string here. In this case, the loading ammo string is called an argument which is passed to our function. Now, if we want to do the same, we have to receive that argument inside of our function declaration here. So let's say I'll receive a loaded value, and then this value will be available in our function block. So let's say I'll just write an if statement like if it is loaded, we will fire. So now let's say I want to indent this block of code. I'll just select them all and then hit tab on my keyboard. All of them will be indented, and then I can just write the else block, that is if it's not loaded. So print, and then I will print something, let's say there is no ammo. Okay, so now here in our function declaration, we receive this loaded argument, and now in our function block, we are checking that if it's loaded, we fire, else we don't. We print an appropriate message. So now we need to change our function call as well, because we are receiving an argument or value when we are defining it. So we need to pass the value when we call it as well. So if we call our fire function as it is, we will raise an error. So let's bring up the terminal, clear the terminal, then execute the Python file. You can see we get an error, that is fire function missing one required positional argument, that is loaded. So what happens, or what this error means, is that required positional argument. So we need to pass the loaded argument if we call the fire function, and it says positional because in our print function we can pass one or more arguments by separating them with a comma. That's why it's called positional arguments. So here let's say we will pass true, it's loaded. So now I can again bring up the terminal, and then okay, so now Okay, let's make it full screen. I'll clear the terminal and then I will run our python app.py. So now you can see because we have passed fire as true, we get this output. Now if I change it to false, that is loaded as false, we will get no output. Instead, we will get no ammo message printed here. So this is called an positional argument. That is when we call a function and if we pass an value, it is called a positional argument. And if we want, we can also define the variable. That is, we can also define the loaded like a variable here. Like let's say the loaded is false like this. This is called an keyword argument because we are specifying the key and its value like our dictionaries. So here, if I again run the code, we will get no ammo printed again. So we can declare our functions, receive arguments, and call them as well with arguments and positional arguments, etc. So what happened here is that when we call the fire function here, this false value was passed to the loaded here, and then inside the function block, it was used as it is, like if it is loaded, because we passed false, the else block was executed, that is print no ammo. So in this lesson, we learned what functions are, how to call them, and what their arguments can be. We'll be using functions a lot, so it's crucial to understand this topic. Now, I may have crossed the line a bit today, which may have made things a bit hard for you to digest. Worry not, just close the computer, come back and give the lesson a watch again. Trust me, you will grasp things faster and easier. Anyway, guys, I think it's time for promotion. That is, you are now a newbie programmer. Even though the title may sound lame, but progress is progress. Diamonds were once scored right. Praises from me for your hard work. Go ahead and take a break because you deserve it. Do you remember the day when you first started learning this course? Compare how you were and now what you are. Congratulations on completing the course. As your instructor, I hope your time with the course was valuable. I tried to make the course as easy and complete as possible. Mostly you will find programming courses with lengthy lectures, which are of course no less than monotonous explanations. I tried to insert some fun elements like jokes, but also kept them minimal so that it becomes fun instead of a headache. Python is one of the languages which enables you to do anything you want, like from building websites to training machine learning models. This may be the end of this journey, but it's also the start of another journey. You can go ahead and build applications to further build your knowledge. I'm also working on a course where we'll build loads of applications like this, or this, or even this. Until then, you can check out my other courses or my YouTube channel for more content. I will leave the links for the same in the resources. That's it for this course, and until next time, see you soon.